Hey Algebra 2 students, this is our second day of notes in the solving unit. So in our first day of notes, right, the notes that you guys watched on Monday's asynchronous, we saw a couple of different big ideas. We saw first big idea was one strategy to solve is to use factoring, right, and that's why we did some factoring review before this chapter. The second big idea that we saw was undoing using a big idea of square roots. Okay, in our second day, we're going to think about the square root idea, and we're going to kind of expand on it. So that's all I want to tell you guys so far is we're expanding on the square root idea. You can just call this in your notes day 2 of solving. Right, we're still in chapter 2. So these equations that you guys see on this screen are nicely set up to be able to be solved by square rooting, right? For the first one, you can kind of nicely see that if I move the 36 to the other side, I'll be able to square root both sides and say that either x plus 5 is the same thing as a 36, or excuse me, 6. Forgot to do the square rooting part. Or x plus 5 is equal to negative 6, right? And then continuing to solve, I'll say either x is 1, or if we do the second version, x is negative 11. And after we solve, checking your answer is always a really great next step, right? We want to double check that everything worked out. So like 1 plus 5 squared. That looks good. Negative 11 plus 5 squared, right? So both of these check out. Now, this is all really nice and accessible. All three of these problems we could easily solve for x if it looked like this. However, what I want you guys to kind of think about today is how do we get to this look if we don't start that way? And so what I'm going to do is I'm going to start with what we like, the end product, and we're going to kind of multiply it out and see what it might look like all multiplied out. So if I do x plus 5 squared, remember, it might be nice to do your area model because you might accidentally just say x squared plus 25 and miss the two 5x's. So that should be 10x's, right? The two 5x's kind of combine right here to make the 10x. Plus 25 minus 36 equals 0. Okay, and then from here we would combine our like terms. Let's see, negative 36 and 25. That's going to be, it looks like negative 11 is equal to 0. And then we'll do the same thing with the next couple. So what I want us to think about is as we try a couple of these, right, we are going this way, right? The question is, how do we get the other way? How to go this way? Because sometimes problems are a little trickier and they start with the bottom version, and it might be nice to be able to make it the pretty square root version, right? The pretty version where we can easily solve with square roots. Now, keeping in mind, sometimes a problem like this, I wouldn't want to make the square root equation happen, right? Some of these equations I might be able to solve by factoring. So this is just an alternative if we get an equation in this form. This is called standard form, and it's not as fun form. So sometimes in standard form, it's nice to make it into the version where we can factor, right? It's nice to go from standard form to factored form. And sometimes it's nice to go from standard form to the top form. So this is called, the top form is called vertex form, and it's called vertex form because we can nicely pull out that vertex. Remember, if we think about transformations, this is left 5 and down down 36. So that tells us that it looks something like this, and that vertex, that lowest point, has the coordinates negative 5, negative 36. So this is called vertex form, just to give you guys a name for it. It's the form that we can use our square root as a strategy. But the question is how to get from standard to vertex form, right? How to go the other way. So I'm going to do a couple more examples, and we're going to kind of look for a general pattern. So I'm going to do this one in a different color just to be easier. And it's x minus 3 squared feel free to use an area model if that helps you remember to keep in mind the negative 3x's, which makes negative 6x's, right? Oops. These two combine to be that. Minus 25 equals 0. And then we're going to put our like terms together, right? And it's going to become minus 16. Okay, and that's standard form again, and we're going to think about as we continue, do we see any patterns to go backwards? Right? How to go backwards. Right? We're just kind of thinking about that in the back of our minds right now. And then let's do one more. This one is going to be x squared, right? We know the 16. There's also going to be two 4x's, and those two 4x's are going to make 8x's. And then from here, my like terms are going to combine, and it's going to be, looks like, negative 84. Okay, so what we want to think about is how to go backwards, because typically these problems kind of start with what's in the box, and we have to backtrack in order to get it into the pretty form. And something like part C, the blue equation, this one, I might not want to solve it by factoring, right? Maybe factoring an 84, it's kind of tricky to think about factor pairs, and maybe creating the vertex form of the equation, right? Maybe going this way might be an easier way to be able to solve the equation. So this is how to get it set up where we can solve with the square root, how to get it into what's called vertex form. So what are some similarities that we're noticing? The question is, how do we figure out where to go from here, right? How do we figure this out? Like if I'm looking at the blue one and I start with x squared plus 8x minus 84, how does this connect back to the original equation? Well, let's see, the 8x, that kind of fits into the square, right? My area model over here. However, I have to keep in mind that it was two 4x's that made the 8. So it kind of seems like there's a idea that connects, I'll highlight in purple, the purple highlights to the yellow highlights, right? It kind of seems like the purple highlights connect to the yellow highlights. I'm kind of looking at this row, right? And it looks like I have the 8x. It looks like what I need to add in, right? What disappeared, right? Because these two were like terms, and so the 16 kind of gets covered. So it looks like I need to figure out how in words to connect the idea that I'm missing the 16, right? And I'm looking back above. Is there a pattern between 8 and 16, right? These two. So there's a pattern between those, the negative 6 and the 9, and the 10 and the 25. Think about how those numbers relate, right? And maybe I'll like write them on the side. So let's try and maybe I'll erase this. Right. And we'll think about what's the pattern between the 10x and the 25, right? The negative 6x and the 9, and the 8x and the 16. Well, I notice that, 8 times 2 is 16, right? But that doesn't work for the 10 and the 25, or the negative 6 and the 9. If I think back to the area model, remember how the 10x came from the two 5x's? And the 8x came from the two 4x's? The negative 6 came from the two negative 3x's. So do the 5's connect to the 25? Does the negative 3 connect to the 9? Does 4 connect to 16? So what you're probably noticing is that the pattern could be summed up that you take the coefficient of your x, right? That's if we think about ax squared plus bx plus c. It's kind of like taking that b number and cutting it in half, right? And then we take that number, we cut it in half, and then we square it. So it looks like I have to take my 8 divide it by 2, and get a 4. And then I do 4 squared is 16. And this kind of seems like the big idea. So it looks like this one needs a 16. Right? But I can't just think about it like adding 16. Right? Adding 16 doesn't really work. So what you want to think about is you can think about it for this one, right? That if I'm adding 16, I have to kind of deal with it from the negative 84. So I have to take 16 out of the negative 84 is kind of how you can think about it. So it would become 16 and the negative 100, which combine to be negative 84. And then we just focus on simplifying this into x plus 4 being squared. Right? So let's try it out. Let's try it out with a new one. We're going to try the backwards process. And this backwards process we call completing the square. And the reason we call completing the square is because the process of starting like here, right? And, or actually the process of starting with what we begin with, this guy, and kind of going all the way down, we call that completing the square because we're trying to figure out what else goes in to make x plus 4 squared, right? Our whole goal is to get it to turn into something being squared. So we're finishing to make it into something squared. So let's try and look back at that as a reference point for the next one. We have x squared plus 5x minus 9. And actually, I'm thinking I want to change this problem. So sorry, guys, for doing this kind of out of the blue. I want to make it, instead of that, I'm going to make it a 20x. So if we can rewrite that to x squared plus 20x minus 9 equals 0. So let's think about it. I know if I'm thinking about my square, right, that the 20 gets divided by 2 into two 10x's. And then I have to take the 10 and square it to get 100. So that means this area model is kind of going to look like x plus 10 times x plus 10, right? Okay, so I know I want it to look kind of like this. Oops, 20x plus 100, right? Because that would create the x plus 10 squared, right? That's completing the square. However, I've got a minus 9 here, right? So I still have a minus 9. So one thing that some people think about as a strategy, because up above with the blue work, we could kind of see the numbers a little bit better. Because 100 is bigger than a negative 9, it's a little hard to see. So what I think about is if I'm doing something, if I'm kind of adding 100 when it wasn't there before, what I can do is I can do add 100 and subtract 100, because this is the same thing as a 0, right? A plus 100 and a minus 100. So really I'm not changing my equation. And then what I can do is I can put these two together and make negative 109. And from there, what's kind of nice, right, is I can think about, okay, so if I took negative 109 and I added 100, that would, if I was multiplying out, create that negative 9. Okay, so from here, if I'm solving with completing the square, right, I've completed my square. If I want to now solve, so this is just this complete the square. And now I'm going to work on the solving stuff next. So here's going to be the solve, right? So I want to get my piece that's squared on one side. And I've got x plus 10 being squared equals 109. Now what's kind of stinky about this one is 109 is not a perfect square. So if I square root both sides, I know that x plus 10 is either equal to the square root of 109 or x plus 10 is equal to negative the square root of 109. So from there, we would have either x is equal to the square root of 109 minus 10, or x is equal to negative the square root of 109 minus 10. Those look like our two solutions. So from there, what I'd like you to do is try number 2, using the ideas that we've been talking about, and unpause the video when you're ready to double check your work. Okay, so as you can see, the process is pretty much the same. You do have to move the 33 to the other side to make it uniform. And then notice I added 16 and subtracted 16. That's like adding a 0. I'm not changing it. If you follow through the work, the answers are 11 and negative 3.